Hello everybody, my name is Evan, and for my biology role model project, I chose John P. Carney, so let me tell you about him. Mr. Carney has a master's and PhD in bioinformatics as well as computational biology from the University of Minnesota, as well as a master in business administration from the U. In his professional career, Mr. Carney has become the Director of Experimental Surgical Services, also known as ESS, which is a research facility right here on campus. He is also a committee member of the International Organization for Standardization for cardiac valves as well as vascular prosthesis. For this project, I had the interesting opportunity to speak directly to Mr. Carney and ask him a couple questions. He had told me that he had always had an interest for science during his schooling, and it was at the University of Minnesota when he got involved at the Visible Heart Lab, which is a facility on campus that is dedicated to doing research and teaching future healthcare professionals. It was here that Mr. Carney developed an interest in surgery, which he then combined with his master's in business and applied it to his professional career. Outside of his professional career, Mr. Carney spends a lot of time with his family and has also become very passionate for the education of future healthcare professionals, which can be seen in his own facility. So, what is ESS and what is Mr. Carney testing there? ESS is a preclinical testing facility that does research on medical devices as well as surgical techniques. It is also unique in the fact that it is the only public preclinical research center in the entire country. Now, what does that mean? This means that companies like Medtronic and Abbott, as well as independent researchers, can bring their studies to ESS to then be tested by John and the ESS staff. Naturally, with the variety of different sponsors, there is a very wide range of research topics that are being conducted at ESS, but mainly it consists of in vivo animal model testing, primarily on cardiac devices, organ transplantation, and is some other general surgical procedures. Currently, there are actually 15 active projects going on at ESS at the time of this recording. So, why did I choose Mr. Carney as my role model? The answer to that is he's actually my boss. So ESS is a very unique facility in that it hires student workers and provides them with a very unique opportunity ranging from assisting in surgeries, organ harvests during necropsy, and a ton of other very cool jobs. And this photo over here is actually myself. And it is through Mr. Carney's stewardship at ESS that I've grown to really admire him and the research that he does. And in addition to this, interestingly enough, Mr. Carney never attended medical school. And despite that, he has accomplished very incredible works. And for someone who is not sure if they want to go to medical school, I'm very inspired by him. So here is a research project from Mr. Carney that I've chosen. In this study, the team at ESS successfully created an animal model that mimics heart aortic stenosis in order to better study transcatheter aortic valve replacements, also known as TAVR. As you can see from the image over here, aortic valve stenosis is a condition that narrows the aortic valve, which restricts blood flow, and this is a very common condition in humans that undergo these valve replacement procedures. However, this condition is not really something that exists in the animal models that are used to study these TAVR procedures. In order to better study these procedures in the preclinical setting, animal models used in the testing are modified in order to better mimic this condition. And for this study, 12 sheep underwent a modified aortic annuloplasty procedure, which involved suturing an annuloplasty ring to the aortic annulus in order to better mimic aortic stenosis. 5 of these sheep underwent TAVR procedures 60 days after the MAA procedure, and over a 140-day post-operative period, these test sheep were then evaluated and compared to the other 7 control sheep. The results of this experiment showed that they had successfully created stenotic segments in the aortic annulus, and that they had successfully modeled human aortic stenosis in these test animals. So this is the figure that I got from Mr. Carney's publication. In figure A, it shows an illustration of how the annuloplasty ring will be sewn into the aortic annulus. And for figure B, that is actually a photo that was taken directly after the implantation of the annuloplasty ring. And it is taken from the left ventricle outflow tract side. To do this, they used an interrupted mattress stitch using a 3/0 braided polyester suture. So what's next for Mr. Carney and ESS? Mr. Carney is interested in continuing to refine and improve his research facility and its role in translational research. Being the businessman that he is always looking for new clients who are looking to conduct their studies at ESS, whether this be FDA submissions, proof of concept procedures, or really just anything that someone wants to test. He is interested in getting their business and doing it at ESS. Additionally, Mr. Carney is interested in continuing to guide and teach the future generation of healthcare professionals similar to how he was when he was going through college. So here are my references for this presentation. The two highlighted ones are my primary sources. And thank you for watching.